Okay, hello class. So today for our very first video lesson, we're going to start talking about expressions. Now, before we dive into expressions and really get into the more difficult stuff, we're going to start with a little bit of a review from 7th and 8th grade. In 7th and 8th grade, you discussed adding and subtracting integers. Now, integers are whole numbers, whole numbers. Whole numbers means there are no fractions and there are no decimals. So we're just looking at integers. I'm going to try to use the word integer throughout the lesson, so please make sure to remember what an integer is. -3, -2, -1, 0, 1, 2, 3, blah, 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 forever. Another way to think about it is the counting numbers, Okay, now, this first problem, we see it says find the sum. Sum is another word for addition, right? And I would be very surprised if most of you couldn't tell me without any thought whatsoever that this is 28. Still getting used to this board here, so be patient with my handwriting. It'll get better, I promise. Now, we see this number line at the top here, and number line was a good tool that you learned when you were in middle school to add and subtract positive and negative integers. Now, if it tells you 8 plus 20, you start at 8, and you make 20 jumps this way. Count them out, 20, blah, 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 and you get at 28. Now, the sloppy handwriting is getting to me a little bit. Okay. Now, let's make sure I'm in the right spot. 28. Perfect. Okay. Now, this next one tells you -15 plus -3. Now, this right here is the same as, let's get back to our pen. This is the same as -15 minus 3. When you are adding a negative, it's the same as minus. Now, to utilize our chart up here, we want to start at -15, our first number, and -3 tells us to go to the left. -1, 2, 3 gives us -18. Okay? Now, looking at our next problem, we have a positive number plus a negative. So this tells us that we have 17 minus 19. 17 minus 19. So again, we started our first number, which is right here, and we make 19 jumps this way, and we are going to end up at -2 after counting 19 jumps. The reason it's negative is because you have a number and you're subtracting a larger number. So that tells you that you are going to have a -2 here, -2. Now, our next problem, -6 plus 20. Again, we start at -6. Oops. Start at -6. And we make 20 jumps to the right. Now, to make 20 jumps to the right, after you have counted it out on your own, you would end up at +14. You were negative, but you added a larger positive number, so your answer is going to be positive. Now, looking at the bottom, we have very similar situations, but one of the big things we need to watch out for is minus a negative, minus a negative. We know that minus a negative from middle school, we know minus a negative is really the same as addition. So instead of minus a negative, we have +5. That is a horrible plus sign. Promise I'm going to get better. Now, subtracting a negative turns into addition. So now we can go back up to our number line. And remember, you only have to use your number line if you need it. If you're comfortable without it, then that's great. We start at -13, and because we're adding 5, it tells us to go in the positive direction. This is the positive direction and the negative direction. 1, 2, 3, 4, 5. puts us at -8. -8. Okay, I'm not going to go any further with this. Make sure to practice these skills on your own, okay? Now, next slide. There we go. Cool. Okay, and I wonder if I can just clear all. Eraser. Ha! Too easy, too easy. Okay. Now we can move on to the expression vocabulary. Expressions versus equations. In green here, we have multiple examples of expressions. In blue, we have multiple examples of equations. I'm hoping you'll notice that the biggest difference between these two is the equal sign. It makes sense. We have equations have equal signs. You'll even notice it looks very similar to the word equal. So equations have equal signs. Today, we're only going to talk about our expressions, and that is without an equal sign. Now, clear screen again. Man, I'm getting good at this, getting good. Okay, now we have equations, expressions, terms. So we'd already talked about equations. This is the whole thing with the equal sign right here, okay? Now, the expression, very similar, is just going to be this portion here without the equal sign, not including the equal sign. And we have terms. A term is just one piece of an expression. So this 3x here is a term. This 5 is also a term. Both of these are considered terms, okay? So 5 and 3x are both terms, but this term, 3x, is made of two different parts. It's made up of a coefficient. That's something that multiplies. Remember, there's a little imaginary multiplication sign here. We talked about that in middle school. So this is 3 times x, right? The coefficient is the number next to the variable that's multiplying. The variable is the letter that we use to represent any number. X could be 5, could be 300, could be 9 million, could be -208. We don't know what this variable is. It could vary, right? Variable. Now the constant here is just something you add or subtract with no variable. Because there is no variable, it does not vary, so it's constant, okay? Good, some good vocabulary here. Now, moving on. Combining like terms with expressions. Now, like terms, well, combining means putting together. Like terms, right here, means terms that are similar. We just learned the term terms. We just learned the vocabulary word terms, right? Now we have 1, 2, 3, 4 terms here. 1, 2, 3, 4 different terms. You'll notice the 3x and the 7x are considered like terms, meaning they're similar. And we can put them together or add them together, giving us 10x. And we can add our 6 and our 3 because they are also like terms because there is no variable. We add those together, and that gives us 9. This is a simplified, because you've made it simpler, this is a simplified expression. Okay, moving on. Clear that garbage out. Cool. Now, I'm going to move through these kind of quick, so hopefully you can practice them on your own. The first one here, we notice we have a 5x, a -2x. This negative is tricky. You got to keep an eye on that negative. And another -2x. If you put these three together, you have 5x plus -2x, or 5 minus 2, which would be our 3x, minus another 2 over here gives us just 1x, and all of our x's have been put together. 5x minus 2x gives us just 1x. And then we have a +4 here. I'll put that in a square. And a +3 here. Neither of these have variables, so we can add those together. Plus 7. Now, this is a great answer, but because we are simplifying, trying to make it as simple as possible, this 1, because it's 1 times x, isn't necessary. We don't need this 1 there. So we're going to keep it even simpler just by putting x plus 7. Okay, x plus 7. Good. Now let's try one of the more difficult ones. Let's try number 4 here. So we have 3p squared and negative 2p squared. You'll notice that these are similar, not because they have the p, because they have a p squared, the p squared. So we have 3p squared minus 2p squared, which leaves just 1p squared. Okay, and we have a negative p and a plus 6p. You'll notice that this was why we practiced adding and subtracting integers before we started this. We had to make sure that we understood our adding and subtracting integers first. So we have negative p plus 6p. If we think of the number line, we end up with a positive 5p. And our last ones, I'll try to do a circle around this. We have plus 2 and minus 1. Gives us just plus 1. This 1 would be our constant because there's no variable. Now we're almost done here, but again we have this extra 1 up here that we do not need. This can be simpler just by making it p squared plus 5p plus 1, and that's it. Okay. I feel tempted to ask you if there's any questions while you're watching a video, so that's not possible. It's hard for teachers to get used to this new stuff, you know? Okay, now we're going to clear that out, and of course you can pause the video if you needed to see that still. Distribution with expressions. This will be the last part of our lesson today. Distribution, when we think of distribution in the real world, we think of maybe like a truck that comes to Walmart to drop off bread, or let's say something more delicious. Let's say avocados. Avocados are good. Everyone loves avocados, or maybe chocolate. That's even better. So they come to the store and they drop off chocolate at Walmart. Well, because it's a distribution truck, they don't just stop at Walmart. They stop at Kroger as well. They stop at let's say they stop at Dollar General as well to drop off more chocolate there and there. So they're taking their chocolate. In this situation, 3 is the chocolate, and they're delivering it to Walmart, and then they're also delivering it to Kroger. Okay, this is distribution. So distributing chocolate, you can also distribute a number. Okay, so because right in front of this parenthesis is a number, it's actually being multiplied. So distributing is multiplying everything within the parentheses. So 3 times 4x gives us 12x, and 3 times 5 gives us 15. Now, this plus sign has not changed. That is still there, okay? So we just distributed that 3. Now, we have a negative 2. We're going to distribute this negative 2 over here. And next class period, we'll practice a little bit more with multiplying and dividing integers. Today, we just focused on adding, subtracting. Next class, we'll focus on multiplying, dividing. So negative 2 times 9, a negative times a positive, is a negative 18. A negative 2 times a 2x squared is a minus 4x squared. Okay, notice the x squared didn't change at all. Just like here, the x didn't change at all. We just multiply the coefficient, the number in front of the variable, by the 3. And the last one here, negative 8 times 7. I put this in here intentionally because I know a lot of people, when multiplying, they struggle with which numbers, the 6, the 7, and the 8. We need to practice these, okay? Now, negative 8 times 7 is a negative times a positive, so we know the answer is going to be negative. And 8 times 7 is negative 56. Minus, now it's a minus because we have negative 8 times positive 6x. So 8 times 6 is 48. Now we have a negative 56 minus 48x. And we have another more simple example over here if you'd like to look at it. Okay? Now, let's see if I can erase all this. And again, you can pause it if you need to.